As we wrap up our unit on functions, we thought we would take another day and look at some story problems, and in this case, a story problem with some graph options where we can think about which graph of a function matches what our story is telling us. So in this problem, we have Rocco right here in the pool. It says Rocco is a hot dog, so his owners decided to fill his swimming pool so he can cool off. The hose will fill the pool at a rate of 2 gallons per minute. Which of these graphs best represents the depth of the water in the pool as it is filled at a constant rate? So constant rate tells us the amount is going in always at the same amount out of the hose. Okay, so it's 2 gallons per minute for every minute that the hose is on. I've drawn a cross section of the pool here because I wanted you to be able to tell that even though this looks like there's a little bit of a slant, for this problem we want to assume that it is straight walls on Rocco's doggy pool, so that as the water's going in, it would go across the bottom, filling it in, and then as it goes across the bottom, it's just going to keep layering on top of itself over and over, increasing the depth, and then the depth will raise as one whole, not with one part getting deeper faster than another part. That's important for this problem to understand that. Okay, so we are given 4 graphs. You can see 2 of them right now on the paper, and as I slide the problem up, you'll be able to see the other 2, and we'll look at each of the 4 and think about what kind of pool would create that kind of graph. All right, so there are the 4. And let's just start with A. In A, here's what I see. As time increases, depth increases by the same amount, giving us a constant rate of change. I'm going to go ahead and label this. It's a straight line, so I have a constant rate of change, or a constant slope to my line. And that's meaning that for every minute, so for as minutes increase, depth increases, and it's running the same. So if you have 2 minutes, the depth increases by the same amount that it did for 1 minute, and at 3 minutes it increases by another amount, and this is just going to consistently go there. So when I'm thinking about that kind of a pool, I might be picturing like a barrel hot tub or something, where I have one depth all the way across the pool, and it's going to fill in, and for every 2 gallons that goes in, it takes the same, so every minute I get 2 gallons and 2 gallons and 2 gallons and 2 gallons, and it keeps on just filling the depth up. Okay, so when I think back about Rocco's, this is actually sounding like a good choice, but I want to go ahead and think about the other 3. Pool B, this graph shows, well, as time increases on the x-axis, first, the depth increases pretty quickly, and then it starts leveling off. So picture a pool where the depth increases quickly, and then the whole pool takes a while to fill out. And what I'm picturing right now would be maybe something a little different than what we have at Rifle Pool, where you have a deep end, and the pool just consistently goes up. So that there's the water level. So that down here, the deep end, when water gets put into this pool, it's going to run down here to the bottom, and it's going to fill kind of quickly here, but because the space is ever increasing, the volume, that's going to then start slowing down how quickly it's filling, because now it's got more area to cover. So this kind of graph shows that kind of pool. So water gets deep quickly for first few minutes, then slows down. Okay? All right, let's take a look at graph C. It's doing something kind of different from what B did. In C, it looks like, wow, it takes a long time for it to start getting some depth. So as time increases, you don't get much depth, and then the depth really starts to increase towards the end. So when I'm picturing that, I really can't think of a pool that represents this situation, but I'm picturing something that's wider at the bottom, so it would take a long time to fill, and then it's narrow at the top. Doesn't sound like a very good safe pool, because look at what I'm thinking about drawing here. Something that's narrow at the top and wide at the bottom. You can see that that would have some health consequences to it. So as the water is going into this pool down here, it takes a long time to start getting some depth, but higher up it gets, the quicker it's filling. So that would give us this kind of graph. And finally, we have this graph over here. I have two sections that have constant rate of change. So we have a little bit of steeper slope here and a shallower slope here. So this is filling a little slower than this part is, but it's two constant rates of change. So you might be wondering, well, what kind of a pool would do that? As I envision it, I have something with a kind of a small deep end that's going to fill rather quickly. So the water will come in and quickly be filling this bottom part here. Then the pool obviously has to widen for it to start having a shallower slope. So I have a deep end, I have a shallow end. I probably don't have a very big pool based on this. And now when the water level gets here, oh, well, it's all going to be filling at the same rate now because there's no change in depth like there was here, but it's a slower rate until you get to the top of the pool for filling it. Okay, so now that I've thought through all four of these, I still think I had the correct one for a rock. I'm going to slide back down here. I think this and this are the same idea, and so that graph A is the correct choice for which one Rocco uses. So I'm going to come on down here to the bottom and say graph A reflects Rocco's pool because it is all one depth and fills at a constant rate. Okay, that'll take care of that problem.